Hey guys, so we're going to start off with what we left off yesterday. So we have to find the vertex form for this equation right here. So if you remember, we were supposed to try and solve this. In order for us to do this, I said that we have to make big squares. And how many big squares do we have to make? Well, in front of x squared, we have -2. So we got to make -2 groups of them, right? And so the first thing that we're going to do, we're going to pull out the -2. But when we pull out the -2, we're going to make sure that we only pull it out for the x squared and the -20x. And then we're going to leave the -54 alone. All right, then there you go. Let's go ahead and find the vertex form. So what do we have to do first? Pull out the -2, right?
Yes, Mom.
And then I said we're going to leave the -54 alone by itself, right? Now what we're going to do is we're going to go ahead and complete the square, but inside the parentheses, right? So let's think about this. We have x squared and plus 10x, okay? And then now we have to randomly add some little squares. So thank you for asking that question. That's a very good question. So then, as I showed you on the board, but not recorded here, okay, so if I have 10 little rectangles, which is shown right here, right, and I have one big x, how many little squares do I need to make a big square in here? Yes, I need 25. And do you guys remember how I got the 25?
Divide 10 by 2 and then square.
Yes, you have to look at this number over here, the 10, because you have 10 long rectangles. So you had 10 of them. You have to divide them by 2, which gives you 5 rectangles on the side like this, and then 5 rectangles at the bottom. That's why you have to divide it by 2, right? And then to figure out how many little squares you need, you had to square it, because it's 5 times 5. You got to multiply the same number twice. Okay? So then if you square the 5, you're going to get 25, which means you need 25 little squares in order to complete the square. But what have I done right now? I have just randomly added 25 out of nowhere, right? So what I'm going to do right now is I'm going to get rid of the 25, okay? So now, normally when we get rid of the 25, we just have to subtract 25. But in this case, we can't. So there you go. Now, I want you to think about this. I randomly added 25, and now I want to get rid of the 25 because I'm not supposed to do that. That was not part of the original equation. How am I going to take away the 25? Am I just going to put -25 on this side? I need to take away 25, but can I just take away 25 out here?
Would you take the 25 from the 54?
I can't just take out the 25. You know why? Because now this 25 is part of what? This -2. It's inside the parentheses, okay? So you got to think in terms of, you made this one big square, but you don't have only one. How many of these do you have now? You have -2 of them, okay? So when you randomly added 25, you didn't randomly add 25. You actually randomly added -50. -2 times 25, okay? So then what you got to do is now you got to subtract 25 times -2, okay? So let's take a look at this. So then you want to subtract the 25, but you can't just subtract the 25 because it was a prisoner of what? The -2, right? And then you got to include the -54. Okay? So there you go. Now let's simplify. Everything inside the parentheses was what? X plus 5 squared. I think this is very important because a lot of you, even the smart kids in first period, because you have this equation, when you write your completed square, okay, you wrote x plus 10 squared. But that'll be wrong because you got to remember, out of the 10 rectangles, only half of them went to the side and half of them went to the bottom. So when you write your equation, it will be x plus 5 squared. So this is very important for you to understand. So now we're almost done, right? So all we have to do is this part. Okay, we got to simplify that part. Don't forget PEMDAS. We want to multiply first, right? So negative 25 times negative 2 is positive 50. And then don't forget this part right here. That's negative 54. So I'm just going to write it out. Okay? So now that's going to give me negative 2 times x plus 5 squared. And then, a lot of you got this part wrong, right? Adding these two numbers. You can use a calculator if you need to, but 50 minus 54 is supposed to be negative 4. Okay? And so now I am done. This is my vertex form. Okay? Now, from this point on, the reason why this is called a vertex form is because it's easy to find the vertex, right? So yesterday in my 4th and 5th period classes, we talked about why the vertex is negative 5, 4, right? So let's see. The vertex is negative 5, negative 4. Can anybody tell me why the vertex was negative 5, negative 4? Yes, Andrew. You are so amazing, Andrew. Yes, because of the formula for the vertex form is a times x minus h squared plus k. Okay? And the vertex is h, k. So x and then minus, but this is a plus, so if you want to change that to a negative, that's going to be the same as x minus negative 5. So your h would be negative 5. Okay? So I'm going to pause here so I could take some more questions. Okay, so just a few things that I wanted to write down for you. The vertex form, the formula, right? So the formula looks like this. F of x is equal to a times x minus h squared plus k. Just keep in mind that the vertex is h, k. And that's why you have a negative 5, negative 4. Another thing, that was a very good question. What is your answer? Is your answer this or that? Well, it depends on the question, okay? If the question asks you to give you the vertex form, then that's your answer. If the question asks you for the vertex, then that's the answer. You need to know what the difference is, okay? The graph, the parabola is this right here. That's the equation. The vertex is this right here. That's the vertex. So your vertex is a point, and that point is at negative 5, negative 4. And the equation for this graph is negative 2 times x plus 5 squared minus 4. This is very important for you to understand, okay? So there you go. I want you to go ahead and work on this practice question. Let me bring up the screen so that way it doesn't look so messy. There you go. I want you to go ahead and switch to vertex form and find the vertex. When you're ready, please raise your hand. Especially if you are needing help, raise your hand so I can help you. Okay? Ready? Go. So there's a lot of confusion. I really want you to watch the video again. Okay? So the correct answer is 3 times x minus 2 squared. And then I think it was plus 6. Okay? And so then the vertex would be what? The vertex would be 2, 6. Okay? All right. And then, so from here, what I want you to do is go into your textbook, page 36, right? Because I told you that is where you have to go. So, there you go, page 35, and they give you an equation, right? And the equation is y is equal to x squared minus x minus 12. And then on the right-hand side, it says what? It says the factored form, okay? Factored form is what we did yesterday. Remember the big X? Okay, so I'm going to go really fast just to show you. What number goes on top, guys? Negative 12, because I told you it is 1 times negative 12. And what goes at the bottom over here? The negative 1. And I told you this is so easy. It's not going to be on the test. Remember that? And then we have to multiply these two numbers. So I used the factor tree. 12 is the same as 1 times 12. And 1 and 12, no matter what we do, we can't get negative 1. So now I'm going to do 2 times 6, nothing. So 3 times 4. 3 times 4 is 12, and oh my goodness, if I subtract 4 from 3, I'll get negative 1. Because I see a negative number here, I know one of the two numbers have to be negative. So either 3 is negative or 4 is negative. I'm going to put 3 and 4 for now. But then when I look down here, what do I see? A negative 1. When I add the two numbers, I should get negative 1. That means if my answer is a negative number, that means the bigger number is the negative number, right? So there you go. The 4 has to be a negative, right? Okay, so then now our very next step that you should not skip is the fraction form. I'm going to put a 1 on top. Why am I putting a 1, guys? Because my leading coefficient over here is a 1. Okay? And then what am I going to put at the bottom? 3 and negative 4, my two answers. Then I gotta see if I have to simplify, right? And I can't. And what letter was I playing with, guys? I'm playing with the X's, no other letter, right? I might try and trick you and put a P or a T, okay, on the test, so pay attention to the letter, okay? And so now my answer is X plus 3 in parentheses and X minus 4. And so that is my factored form on the right-hand side. Now below the factored form on your textbook, it says graph of the equation. In order for you to graph that, you actually have to use your Chromebook and go into Desmos, okay?
I know you said you use your Chromebook and use Desmos, but on the SAT, we all know we can't use our Chromebook. So is there any way we can do it?
So I just got a really good question, right? Unfortunately, not even though in the real world you can use graphing calculators all the time, when you take a test for college, right, they don't let you. And so what if you're in a situation where you have to take the test and you cannot use your graphing calculator? That's what I was trying to explain to you. If you go into Desmos, right, and then if you were to graph this, okay, let's say you punch in whatever number you punch in, that's fine. You can go ahead and punch in this equation, or you can go ahead and punch in this equation because it's exactly the same thing. Okay? It's just in a different form. This is in a factored form. The other one is in a standard form. Okay? But guess what happens? When you graph it, the graph is going to look like this. You're going to have a parabola, okay, that passes through negative 3 and 4. Okay? And it's going to be a smiley face and not a sad face. Okay? And if we did not have Desmos, we can actually draw this graph, okay, by ourselves. And we have all this information because we were able to change this standard form up here, this is standard form, okay, into factored form. And that is the whole point of this module, okay? You have to understand that when you have an equation, you can change it to standard form, to factored form, to vertex form. And the reason why, so if I were to change this, this standard form up here into a vertex form, what would that give me? The vertex. So then I will be able to find out what my vertex is, which is going to be over here. Now, I don't know exactly what the number is right now because I didn't change it to vertex form yet. And that was what I was going to try and make you do next so you can find the vertex, okay? So when you're taking your SAT, because most of you are going to college, right? And they tell you to graph this and, oh no, you can't use your Desmos calculator. This is why you're learning how to convert from standard to factored form, because now you know the 2 points where the parabola is going to pass, and you know it's a happy face because this number at the front is a positive one, not a negative number. And then now you got to switch that over to a vertex form in order to figure out what your vertex is going to be. Are we good? That's why we were doing this. That's like the best question anybody would ask me, Andrew. Okay, so now we want to find the vertex form just because we need to know how to graph, because we're all going to go to college, and not only that, we have the Common Core state testing that we have to work on. So there you go. Y is equal to x squared minus x minus 12 was the equation. Okay? Yes. So another very good question. We were using our models, right? And so if we only had one rectangle, how can we make a square? Well, using the model, we can't do it. But when we are using math, we can. It's kind of like cutting the big square in half as well, okay? So let's go ahead and do this, okay? Y equals x squared and then minus x, right? So then I need to know how many little squares I need to add and leave the negative 12 outside. So what did I say you gotta do? You gotta use this number, which is negative 1, divided by 2, right? So then you get negative 1/2. Then you gotta square it to find out how many little squares you need. That gives you 1/4. And so basically, what do you have to add? You're going to have to add 1/4. Because you randomly added the 1/4, now you gotta subtract the 1/4. Okay, and don't forget the negative 12. And so now if you were to go ahead and write the completed square, it's going to be x minus 1/2 x, 1/2 squared. Okay, and that is what's inside the parentheses. If you're asking me how I got the 1/2, I just divided this negative 1 by 2. Okay, and then I have to add the stuff on the side, which is negative 49/4.
You said you divided negative 1 by 2?
I did, yeah. Because if I had 10, I had to divide 10 by 2, right? Kind of like that. So even if I had only negative 1 rectangle, you divide by 2. I know. Yeah. Okay? Yeah, no, but then you have to square it to figure out how many little squares you need, right? Okay, so then now what is your vertex, guys? 1/2 comma negative 49/4. So then you know that if you wanted to graph this is going to be at 0.5 comma what? Negative 12.25. Okay? Sit down, please, guys. Going back to the graph, okay? This point is at what? This is at 0.5. This point is at 0.5. And then this point is where? At negative 4.25. And now you can completely draw your graph accurately. Okay? So this part was a little bit difficult, but it's the same thing for every single question from this page on. But I told you this type of question is too easy for you. Most likely on the test, I'm going to give you something like number 5 on page 37. Or number 6 or number 7 on page 38. Okay? I need you to look at those. Shh. Bye, guys.